Audio check.
Now and clear. Good morning.
Thank you.
Did we miss a cancellation notice or something?
I did not see a cancellation notice for this morning's call.
No, actually, I just see a email saying that it's still on. Yeah, calendar notice. Okay.
Are we on the right Zoom link? That's the next question.
I think so.
Well, we could not all be on the wrong one. That would be
Well, yeah, that's true. It's this whole welcome to a new series meeting notice. I'm like, well, new since when? Am I still on the old one?
Hi everyone. Sorry I'm late.
Hi, Bobby.
Hi again.
Hello.
And I think there's the OIF meeting this week. So there's seems several people has conflict about the meeting today, and so I would just like to work with us about one of the outstanding items that about the channel the session 4, which is the one that I think it's the most difficult, which is the most important part about the optical technology in so let me share it in here. But before we diving into that, I'm still we have several more people's agree to and like to join for the workshop talk. So, but there's still a few more spots available at the moment. If you and your company are willing to share your technology or have some thoughts like to share in the OCP meetings, this would be the fantastic opportunity to jump it in. And so, it's easy to sign up. Just shoot me the email and let me know your interest. Then once you have the titles and abstract ready, just let me know so I can prepare the list and send it to the OCP, and they will update the website. So go back to the white paper part. Again, thank you for people who's willing to help, and so far we have received some works already, and I start reviewing it. I think I only have time to read through Raymond's electrical interface. I think the way to working on it is wonderful. It's very easy to edit into when we are working on the rest of the paragraphs. Try to integrate it together and very clear for the pictures and the reference. So I think that's exactly the formats that I think we should doing it, because there will be some edit in after that. So for people who is still working on, you can go checking the drive in here. You can just go and kind of check the drawings and the sessions that Raymond did a little bit, and just kind of mimicking the format, because I think that the way that he did was really good. So I'll go back to the session 4. This is the sessions that we're gonna put the informations for the optical components, original ways that Jeff architectured it is he's working on the retime architecture, then the form factor, then the electrical interface, then the optical interface, and then the different connector topologies, other things. So then it was a couple of weeks ago, we said, oh, we should talking about different modulation technology. But different modulation technology is kind of tangled with the wavelengths and the the speed choice. So it feels like it's hard to just carve another sessions just to talking about the modulation technology, but how to make the things that feels more systematic. So I kind of go through my head and realign the things a little bit, but this is still undergoing, and I just like to collect some thoughts and feedbacks about this, the train of thought. So hopefully when I have when after this meetings, I'll continue working on it, then we can create something that is it's fitted into our paper in a better way. So so this is what I thought about it, is we should move the electrical interface at the very beginning, because every technology that always have to convert between the EO and OE. So E is always at the beginning and at the end. That's why the electrical interface has to be taught at the beginning. Then we kind of just following through how the things that converted. So electrical interface, then you try to convert it to the optics. So the main big part would be how the format would be, where do we put the form factor. So it will covering to the CPO, MPO, and OBO, and pluggable, and maybe the CPC in here, because the different electrical interface would tie it into a different form factor that would require a different electrical interface. Either you pick with the something like the XSR or die-to-die interface, then to the MR or LR, just to put the optical module further away from the electrical chip. And once you pick the place to put your optical module, then we start talking about how that module would look like, because inside the module, are they going to be fully retimed, or they're going to be partial retime, or no retime, right? So that's start happening inside the module. Then once it happens, once we figure what architecture the module it is, then we start cut it into a different speed. So then we have the high speed, a slow and Y, and slow and very Y. Then depends on different kind of a speed or the design choice for the architect. Then different speed, you would use different kind of light source or modulator, and maybe because of these modulator, you're going to use different fibers, different PD, and then based on all these things, we will come up with a parameter for the benchmark. And I think we have we mentioned some of the key metrics in here. So all these things can refer back to the metrics, and then the same things applied to, for example, slow and Y. You may change the light source into different things, or the more traditional ways to do so. For example, maybe the ring modulator would have a different design that is more slow and Y compared with just a Mach-Zehnder, and also some of the technologies that we can keep pushing the modulator into a next level, 400G, that can be put it into the high-speed session, and the slow and very Y that can be talking about something like LED technologies, or maybe more traditional technology that can be still reliable, but with a different form factor, so it can be high density and other things. So after this, then I think, with all the benchmark that that we can put it into the different optical technology that would help come out with the network architect to make their final decision about how do they want to build up a scale-up network. So
Hey, Bobby, this
Yeah.
is Mike. When you say
Hi, Mike.
benchmark,
Mhm.
what exactly do you mean by benchmark? You just mean performance specifications? Or are we trying to come up with a new benchmark for an interconnect or a new figure of merit?
No, I think it's I shouldn't set the benchmark. I think I should set what kind of technology of every technology has its key metrics. I should refer to two key metrics instead of benchmark. The metrics that we mentioned in the session 3, which is like the energy efficiency, the I don't know how would that convert into the watt, but I think we can, as it's the optical part, we only focusing on, for example, the energy efficiency. When we have the different design, then you probably have a different radix, different reach. These are the I shouldn't say kid. Yeah, I should change that right away.
Do we want to use the figure of merit developed by DARPA? Where they have
You
that
mean
famous chart, the famous.
the power picojoules per bit per distance things?
Well, the DARPA chart from Keeler has the bandwidth density and the energy efficiency on the y-axis and the reach on the x-axis. So that chart is something that's very well known. You may want to look at that figure of merit from the DARPA Gordon Keeler framework, because of course that will show where this initiative is different compared to the other transceiver and optical activities, both within OCP and in the broader community. And then it will also show where this is relative to the electrical links.
Yes, but I think that one could
Bobby,
Can't hear
we've
you.
lost your audio. You're very faint.
Oh, is it better now?
We can hear you, but it's very faint.
Oh, where's my microphone?
It's better.
How about
better.
this? Oh, okay, yeah, my microphone just turned the other way, so that's probably why. So I have to secure it into the right position. So I think that chart is very important. I think we should put it into the white paper, somewhere in the white paper. But I don't know if integrated into the session 4, which is all about the optical technology, is a very good place to do so. Because the
Yeah, from your description, Michael, it should be up front to say what the scope of the white paper is, right? I mean, from what you're saying.
I'm saying
Yeah.
things. The first thing I'm saying is it's a very famous diagram where you have bandwidth density times energy efficiency on the y-axis and the x-axis is reach. So it's something that readers and people will resonate with because everybody's seen it before. The second point is then you can put a region on that chart that is relevant to the more traditional photonics initiatives, some of which are in OCP, that are focusing on longer reaches, 30, meters, 100 meters, 500 meters, whatever it is. And then all the way on the left side of that chart are the very short reach die-to-die electrical interfaces. And what you can do is show a region on that chart that this initiative is targeting. This initiative is targeting a region on that chart that other initiatives aren't specifically targeting.
Yeah, I think this is a very good one. Really good suggestions. I think we can put that into.
Are you familiar with the chart I'm referring to?
Yeah.
Okay,
I
fine.
think
maybe I'm sure you can pull up a copy at some point and stick it in as
yeah, I think we have that somewhere. In the old presentation. I couldn't recall. So I understand that, and I think that would be a very good one to transition from the to showcase like what is the regions that we are looking for, and but I think isn't that could be somewhere in the somewhere maybe at the very beginning of this white paper, because I think that's what the scale up network we telling about, especially when you're mentioning about the distance, right? The distance in that chart, then that would be the box of the region, that the distance that we're targeting at. So so we can just put a square or into that chart, and then then people would know what this paper is targeting at.
So in addition to that, which is very valuable, region of that chart that is applicable to this effort, that's very important. That's the basically figure of merit of the photonics engines. But since this effort is part of OCP, a lot of people are thinking about integration of these things into packages, into chassis and other things. So for that also, it would be good to talk about things like attach points, shoreline density, beachfront density on die or on the package, and connectivity, the number of ports that a particular engine can export so that scale-up network is more efficient.
Yes, that's a fantastic suggestion, and I think what we try to address is in the chapter 3, we like to bring up all these metrics. So kind of have introductions to the metrics in here, and then and I think I didn't finish it. So, but that is the good things about it is, in the chapter 4. When we introducing all these different optical technology, and I would like to have sessions, a small paragraph in each sessions and talking about how these technology would convert into these key metrics. So like you said, the designer, when they are working on some of the integration idea, they can refer it into the key metrics. So that would be very helpful for them to design. So any other ideas about how we we can reform the session for? Do you think that the this kind of the format change, from electrical to packaging to the timing architecture, then the optical is a good idea, or the more breakdown into a different sessions that Jeff originally proposed is better, or is there somewhere in the middle ground that we can mix it together?
So Bobby, at least for I have put down,
Mhm.
and what you just mentioned, I think the transition that you mentioned as the alternative probably is a good idea. Because I put down optical channel topology there, I should have been more careful. It's really more like a placeholder. If you have actually written what I have, if you have actually read what I have written down, it's just listing out a logical places, how when where electrical would switch to optical. So we have multiple options. And the way you list out here, maybe even move my item number 3 down to the down one section below, the form factor placement. Yeah, that may merge and transition more gracefully, and then the rest of the right paper can really focus on the optical, because my electrical really is a small part of the white paper.
Hey, Bobby, I have to go right now, but also I don't see any comment in here about VCSELs or multi-mode. And
Yes, I'm trying to put it into the high speed. I'm still working on it, but this is kind of like just a framework. So I think for example, the high speed can be the VCSEL, but how does that VCSEL gonna affecting the um, how high it can it be high, right? Somewhere around like this session.
there are plenty of people working on lower speed VCSEL arrays with high numbers of lanes. So
Right.
I think you basically have a silicon. You have a single mode. You have a bifurcation between single mode and multi-mode,
Mm-hmm.
which you have to articulate in this because VCSEL-based AOCs and VCSEL-based transceivers and high density arrays of VCSELs are clearly a contender for this market sector, which which can be slow, however we're defining slow, but they can also be pretty high speed. 100 gigabits per second per lane has been demonstrated. So, but I do think you're missing in this outline the whole VCSEL opportunity.
Oh yeah. I need to add more, especially the modulator part. But you bring it up an interesting point. It's what is the breakdown between the high speed or slow and why? Like how slow is the slow? So maybe that could be
I
a
don't know
very
if we
interesting
should,
part.
I don't know if we need to make these black and white divisions, right?
Mm-hmm.
Between just in the structure. I mean, I think we have multiple optical technologies here.
Mm-hmm.
I mean, directly modulated lasers include DMLs and VCSELs. I've also heard some people advocate multi-mode silicon photonics, so it's not common, but it's not, physically out of the realm of possibility. So maybe it's not something where, that the structure so clearly puts things in categories. Maybe we just say, here's a variety of optical technologies, and then under each one, the comment can be, that these are the strengths and weaknesses of each technology. And so I would skew towards applications, but not be just, completely assigned up front.
Yeah, I think that's what originally Jeff liked to do. And that's what I was kind of struggle in between is it's hard to like you said, it's hard to break it down into different category, but I like to kind of form a better structural way to tell the story. So that's why I like to hear any suggestions about this, how we can form this sessions better. Yeah. So I think we're about time. And again, please let me know your thoughts about it. Don't hesitate to shoot me any emails. And also if you like to participate the workshop, and please just shoot me the email. Thank you, everyone, and we will see you next week. Thank you.
So you meet every other week at 7:30?
Every week 7:30.
Every week at 7:30. Okay.
Yeah.
Thanks.
Thank you, Sam. Bye.